let's work this integral problem. Let f be continuous on AB. We want to prove that the integral of f of x dx between a and b in absolute value is less than the integral of the absolute value of f of x dx between a and b. Okay, here we can give some geometrical explanation for this result here. So if we assume that our f is something like this, so this is and this is my interval a b, the integral of f, so this is my f, between a and b is going to be this part and this part. When I add them, this is positive, this is negative, so the integral is going to be something like this. In absolute value, I'm going to get only this part, something like this, okay? But if I integrate the absolute value of x, of f of x, I'm going to get this part plus this part. And this means that, so this is the integral f of x dx between a and b, and this one here is the integral of the absolute value of f of x dx. Okay, so now we want to prove this result here in general using algebra. Okay, one key idea to prove that is that we know that f of x is going to be trapped between minus the absolute value of f of x and the absolute value of f of x. Okay, so f is always in this situation. For instance, if we think of our function here f, so f is going to be trapped between the absolute value, let me write it here, so the absolute value here, this is the absolute value of f of x, and minus the absolute value of f of x dx. Okay, it's going to be between these two here. Okay, so my f is always going to be here. Okay, so this is my f. It's trapped between these two. My f is here. It's trapped between this one and this one. Okay, now I can use integration and rules of the integral. Okay, because remember, if I have f less than some g, then I can integrate between a and b without worrying about the order of integration. Okay, and here I can do the same thing. I can this is a minus sign. I can take the minus sign outside when I integrate. Okay, so this is the integral. The absolute value of f of x dx is less than the integral between a and b of f of x dx. It's less than the integral of the absolute value of f of x dx. Okay, I had to take the minus outside because I know that if I integrate here, I can use this fact here that the integral between a and b of lambda f of x dx is lambda times the integral. And if I take this lambda to be minus 1, I can take it outside. This is what I use here if you are interested in more explanations. Okay, now how should I conclude from here to here? So I know something. Okay, so let me use a different color here. Okay, so if I have some b, bigger b, less than a, so I know from algebra that b is gonna be trapped between minus a and a. Okay, so if I let b, big B, be the integral between a and b of f of x dx, and if I let a be the integral between a and b of the absolute value of f of x dx. Okay, so from here I see that b, okay, this is my b and this is my a, and using this result here, okay, this is the same, they are equivalent. This is the same as this. Okay, that means what? That means the absolute value here of b, which is this one, which is the integral between a and b, f of x dx, is less than a, which is the integral between a and b of the absolute value of f of x dx. And this is what I needed to prove. Okay, so this is what I needed to prove. Okay, so we had to explain the algebra, how we get this result, and we give some geometrical explanation, okay, for that. Okay, and I think that's all we need here. Pay attention to these two. Okay, so this is the key. So the absolute value of b less than a means that b is trapped between minus a and a. I have used the same thing here when I had to explain this one here. Okay, if you see any errors or mistakes, please let me know. Thank you.